It's time for Maths with Mr. Thomas.
Heidi ho, let's go. So here is chapter 14, lesson number 7. This is the review lesson. Remember, this is just the key points from all the lessons in this chapter. It does not include every slide and every example, so if there's anything you're unsure of, just like the other review lessons, go back to the individual lessons and look at them. So, chapter 14, further calculus. Let's go for it. So at the start we looked at differentiating both sin x and cos x. If you differentiate sin x, you get cos x. If you differentiate cos x, you get negative sin x. There is this little diagram. If you write down sin, cos, negative cos, or SC, negative S, negative C, then to differentiate means you are going down the way. So sin becomes cos, cos goes to negative sin goes to negative cos goes back to sin. If you integrate, you go the other way, but we will get on to that. That sometimes helps you out, so if you have to differentiate, for example, for sin x, well, the 4, it's a constant, is staying as it is, but the sin x, well, looking at this, sin goes to cos when you differentiate, so that would become 4 cos x. We looked at more examples. This one here, 6 cos x plus 5 sin x. Well, 6 cos will go to 6 times cos x goes to negative sin. So we've got 6 times negative sin x. Put the negative at the front, so that's negative 6 sin x. And 5 sin will go to 5 times sin becomes cos, so it's 5 cos x. We looked at more examples. This one here was very similar, but we also had this root x. Remember, you cannot differentiate when you have x in the bottom of a fraction, or if you have any roots. So the first thing you have to do is rewrite any roots, and then you can differentiate. There were other examples. This one here, we had 3 plus x cubed cos x all over x cubed. Remember, there are two different ways to work that out. First of all, two different ways to rewrite it. You can do it the way it's done here. You're thinking the 3 is divided by the x cubed, and also this x cubed cos x is divided by x cubed. So you can split it up into the two fractions. What you can also do is you could imagine brackets around the top. So 3 plus the x cubed cos x, and then move this x cubed up to the top line. So it would become x to the power of negative 3 just beside the brackets. Then multiply out the brackets. If you do that, you still get the same answer here. Once you've done that, you will then differentiate each part separately. After that, we then did some more examples. This one here was looking at working out the gradient of the tangent to the curve. And we all know to work out the gradient of a tangent. How do you work out the gradient of a curve at a certain point? Differentiate! Excellent. So you would differentiate that. And then if you're wanting the gradient at the point where x is equal to pi, you would replace x with pi. And you can work that out. This example here was looking at the equation of the tangent. What are you always thinking when you're wanting the equation of a tangent? It's a straight line. That's right, gradient point equation. So work out the gradient by differentiating. Get the point, you need the x and the y value, and sub everything into the equation. Y minus b equals m bracket x minus a. I'll talk over this in the lesson, so if you look back to the other video, I'll go over this in a lot more detail. After that though, we then looked at the chain rule. If you are asked to differentiate, for example, y equals x squared plus 5 all to the power of 8, well, you could always multiply out your brackets first of all, but if you did that, it would take you a long time. So there is a different way to do it, and that is known as the chain rule. So the chain rule, you differentiate outside the brackets, leaving inside the brackets alone. Then you differentiate what is inside the brackets, and once you've done that, you then multiply both parts together. This example here was showing you could always multiply the brackets, and if you use the chain rule, you get the same answer. But you would really use the chain rule if the power here is going to be 3 or more. It will just save you a lot of time. So here we were differentiating 2x minus 4 all to the power of 7. So bring the power down, take 1 off the power, differentiate what's inside the brackets. You're leaving the brackets as they are for this bit. Differentiate that, you get 2, so you would multiply by 2. So 7 times 2 gives you 14. We did quite a few examples with that. This one here, again, we've got brackets to the power of something. So bring the power down, take 1 off the power, leave the brackets as they are. Differentiate what is inside the brackets. Woo! 4x plus 5, and then multiply by the 4x plus 5. Make sure you've got brackets there, Adam. You need those brackets because you're multiplying everything by the 4x plus the 5. And that is what you would get. Here we had 3 minus x to the power of 1/3. You're doing it the exact same way. If you get fractional indices, it's no different. You still bring the power down. You take 1 off the power. You leave the brackets as they are. Differentiate what is in the brackets. You get -1, so multiply by the -1. For some of these slides, I've got a dot rather than a time sign. It just means the exact same thing. From here, we are rewriting this with positive indices, and that is what we got. Other examples, well, here we've got root signs, we've got t in the bottom of a fraction, so we can't differentiate straight away. We need to rewrite that. So we can write the square root as the power of a half, so put brackets around that. That goes to the power of a half. Then move it up to the top line, and it would become to the power of -1/2. So we've got 2 times all those brackets to the power of -1/2. From there, do the same thing. Bring the power down, take 1 off the power, leave the brackets as they are, and then multiply by the derivative of what is in the brackets, which is why you're multiplying by the 2t take away 3. From there, you can rewrite that, you can simplify it, and you can write it with the positive indices. It may be worded slightly differently. Here we're asked to work out the rate of change of f of x. Andrew, what does the rate of change mean?
Differentiate.
Yes, so you differentiate. Again, you've got brackets here, it's to the power of 4, so you're thinking chain rule. So bring the power down, take 1 off the power, leave the brackets as they are, multiply by the derivative of the brackets, and simplify that. From there, it's the rate of change when x is 2, so we just then replace x with 2, and you get your answer. We can also apply that to other questions. Here we're wanting the stationary point for the function. So stationary points, again, you're thinking you want the derivative, so differentiating. Stationary points occur when f dash x equals 0, so you can find out that value of x. Remember, when you have a stationary point, you need this nature table. You need to prove if it's a maximum or a minimum or a point of inflection, so put that in there as well. You're asked for the stationary point, you know the x value, you want to work out the y value, so you can sub x into the original equation. That gives you y, and therefore you can state what that point would be. Again, I'll go over this in more detail in the other video. This one here, we're wanting the equation of the tangent to the graph of y equals the 2 over 4x minus 1 at the point where x is 1. Again, it's the equation of the tangent when it's the gradient. When it's the equation of the tangent, you're thinking gradient point equation, a straight line gradient point equation. So differentiate to get the gradient. You're subbing in x equals 1, so you're finding out what the gradient is. So gradient point equation, you need the point, you know x, you can sub that into the original equation to work out y. That will give you the point. After that, you know the gradient, you know the point, so your y minus b equals m bracket x minus a. After that, we then applied both of those lessons together. We've got the chain rule, we've got trig, and boom, we smashed them together. So here we had some examples where we were having to differentiate, but we were differentiating, for example, sine 5x. Now sine 5x is different from just sine x. We've got the sine of the whole thing, it's the 5x, so we had to imagine brackets around that 5x. And we've got the brackets there, we're thinking about the chain rule. So differentiate outside the brackets, leaving the brackets as they are. Remember this little diagram, sine cos, negative sine, negative cos. Sine goes to cos. So we've got cos 5x, find the derivative of what's in the brackets, that gives you 5, and multiply them together. So if you're linking them in, you get 5 cos 5x. We did quite a few more examples like that. This one here, very, very similar. Y equals cos 3 minus x. So differentiate outside the brackets. Cos, if you differentiate, it goes to negative sign. So we've got negative sign. Leave the brackets as they are. Work out the derivative of the brackets. You get -1. Multiply the -1 and the -1 just gives you +1. So we're just leaving that as sine 3 minus x. More examples, again, the exact same thing. You're differentiating outside the brackets. So sine goes to cos, leave the brackets as they are, find the derivative of the brackets and multiply by that. You normally put that first. If you get any terms, put them before the sine or the cos. So we'd have the 2x plus 1 cos x squared plus x. More examples, this one here, slightly trickier. We've got the cos cubed x. First thing you need to do is think what that means. Erin, what does that mean?
Cos x cubed.
Yes, so rewrite it as cos x cubed, as Ern says. Then you can apply your chain rule. Bring the power down, take 1 off the power, leave the brackets as they are, and then multiply by the derivative. If you differentiate cos x, you get negative sine x. We're multiplying by the negative sine x. Remember, if you've got cos x all squared, you can write that as cos squared x. This example here, well, x was in the bottom of a fraction, so we had to move it up to the top, but it's cos of x that's in the bottom, so we move the whole thing up, so we get cos to the -1. And again, from there, you just apply the chain rule. Bring the power down, take 1 off the power, multiply by the derivative of the brackets. And you're rewriting it with positive indices. With this example, again, it was very similar. We've got brackets here, and we were having to use the chain rule, so we're bringing the power down. We're leaving the brackets as they are, take 1 off the power, and then multiply by the derivative of the brackets. So it is very repetitive. This is quite a few examples to help you out. With this one here, slightly harder this time. We've got the 1 over 3x. We know we can't differentiate when x is in the bottom of a fraction, so we're moving that up first of all. With the root x, we'll square root to the power of a half, so we're moving that up, so it becomes 2 sine x to the power of -1/2. And then from there, you're just differentiating this bit the way you normally would, and then to differentiate this, you'll be using the chain rule, and you will get your answer. More examples here. We had sine squared x, which you know is sine x all squared, cos squared x, which is cos x all squared. We can apply the chain rule for each part here, and we get 0. But remember, your trig identities, sine squared x plus cos squared x equals 1! Woo! So you can rewrite that, and then you can differentiate 1, and you just get 0. So there are sometimes other ways to do it. Look for little tricks along the way, if there's any quick ways you can do them. This example here, find out the gradient of the tangent. Well, that's very similar. We know we're wanting the gradient, so we differentiate, and again, you're subbing in that value. It's very similar to some of the questions in those other lessons. After that, that is us dealt with all of differentiation. We now know all the differentiation that we need to for higher maths. We then looked at further integration. And when we're integrating, but again, we've got brackets such as this, 3x minus 4 all to the power of 5, we again have to apply another method to work that out rather than just multiplying out brackets. So this time, if you're integrating, well, you add 1 to the power, you then divide by the new power, but you also have to divide by the derivative of what's inside the brackets. Notes here for this. N cannot equal -1 here, because if you add 1 to -1, you get 0. So we'd be dividing by 0. For that, you would have to use another method, which will be introduced in advanced higher maths. And also the expression inside the brackets must be linear. So you cannot have an x squared inside the brackets. We'll look at some examples, such as this one here, 3x minus 2 all to the power of 4. Add 1 to the power, divide by the new power. But then differentiate what's inside the brackets and divide by that as well. So we'd get the 3x minus 2 all to the power of 5 and then divide by that 15. Don't forget, when you're integrating, if there's no limits, what do you have to add on the end, Ms. Amel?
Plus C.
Yes, you need your plus C. This example here, dx, rather than writing it at the side, we just wrote it at the top. If it is there, well, it's really 1 dx. You just imagine a 1 on top of your fraction. So x is in the bottom, we've got to move it to the top, so move everything up. So we've got 3x plus 1 to the power of -5. Add 1 to the power, divide by the new power, but we're also differentiating what's inside the brackets, and that's 3, so we put a 3 in the bottom as well. Multiply them both together, and you get -12. Putting the negative just to the side and keeping the 12 in the bottom. Rewriting this with a positive index, we're moving the 3x plus 1 to the -4 to the bottom, so it's 3x plus 1 to the power of 4. And again, you've got your plus C. This example, very similar. We're adding 1 to the power, dividing by the new power. Don't be put off if you see a fractional index. Remember the quick way of adding or subtracting 1 to the fraction, you just take the top and you add the bottom, or subtract the bottom. So here, we're having to add 1 to the power, so 1 add 2 is 3. We're working with half, so it becomes 3 over 2. And we divide by the 3 over 2. The derivative of 2x take away 7 is 2, so we've also got the 2 in the bottom as well, and multiply them together. And the 2's would cancel out, leaving you with 3, which we leave as it is. We looked at more examples, just getting slightly harder. Here it was dx over the cube root of 6x minus 5. Well, you know the cube root means to the power of 1/3. Think about flower power for that. Look back to the other videos if you are unsure. So that's to the power of a third. Move it all up to the top, so it's to the power of -1/3. And again, you can then integrate. Add 1 to the power, divide by the new power, and you're also dividing by the derivative of what's inside the brackets. Simplify that, and you get 4. And again, you've got your plus C. Make sure you don't forget that. The only time you don't need it is when you have your limits. Here, we're integrating between 4 and -1, so you don't need your limits there. Add 1 to the power, divide by the new power. Differentiate what's inside the brackets, divide by that as well, simplify it, and here we get 2/15 of the square root of 3x plus 4 all to the power of 5. But because we've got limits for -1, we've got square brackets, and we're then going to sub in the 4 and the -1. Sub in 4, sub in -1, you are subtracting them, and then you can get your answer. After that, we then looked at integrating sine x and cos x. And remember, if you have y equals sine x, you can differentiate it to get cos x. If you have cos x and you differentiate it, you get negative sine. If we reverse that, then we're going to be integrating. So, to go from sine x to get cos x, you differentiate. So if we had cos x and we integrated it, we'd get back to sine x. If we have cos x and we differentiate, we get negative sine x, which means if we have negative sine x and we integrate, we get cos x. But if we have positive sine x and we integrate, we would get negative cos x. You got it. And you've also got the plus c. This is where this diagram will help you once again. Sine, cos, negative cos. Differentiate, you go down. And when you integrate, you are going up. It may help at the side, just write down sc, negative s, negative c. We tried some examples. This one here, we're integrating 5 cos x. So we're starting with cos, we're integrating. You're thinking d for down, I up. And cos goes to sine. So we'd have 5 sine x plus c. We did quite a few examples with that. Sine x, if you integrate that, we're going up. So we're going to write the way down to the bottom here, start again, and we'll have negative cos. So that will go to negative 2 cos x. And negative cos would integrate to become negative sine, which is where that comes from. And again, you've got your plus c. Woo! Example 3, we're integrating again, but we've got limits. So we're integrating cos x. We know when we integrate that, we get sine x. Put in the big square brackets, we've got pi into pi over 2, so sub them in place of x, so we've got sine pi minus sine pi over 2, work them out, use your graph to get the values. Remember, pi is 180, so the sine of 180 is 0, pi over 2 then, 180 divided by 2 is 90, so sine of 90 is 1, so it's 0 take away 1, which is negative 1. Some more examples with that. Again, this one's very similar. We had sine, we're integrating it, so we know that's negative cos. We've got these limits here with pi over 3 and pi over 6. We're subbing them in. Think about them in terms of degrees. Pi is 180, divided by 3 is 60, so we're thinking negative cos 60 and cos 30. Use for that the exact value triangles, or the table, or Chelsea's TikTok method, whichever way works for you. With that, you get root 3 take away 1 over 2. Make sure you do know the triangles or another method. This example here, we had to calculate the shaded area. Hopefully you remember the shaded area from lesson 9.5. Work out the area between two curves. If you don't, you may wish to go back and look at that video. But here to work out the shaded area, it is the top curve minus the bottom curve. You're integrating that, and you're integrating between the x values at the start and the end of the area. So here you can see it starts at 0 and ends at pi over 3, which is where the 0 and pi over 3 come from. And the top curve is the root 3 cos x, and the bottom is that sine x. So you are subtracting them. Integrate them both, put in the big square brackets. We've got pi over 3 and 0. Subbing in pi over 3 and 0 in place of x, sub in pi over 3 first of all, take away what you get when you sub in 0. You're working them out, and you will get the area to be 1 squared unit. Yes, you do. After that, we then looked at integrating sine ax plus b and cos ax plus b. So when integrating them, again, you'll notice it's not as easy as sine x and cos x. You will have brackets. It may be the sine of 2x or 4x or the sine of 3x minus 7. Again, it's the sine of something that you would work out first of all. So you've got to deal with those brackets. So how do you deal with the brackets? Well, once again, you integrate outside the brackets, leaving the brackets as they are, and then you work out the derivative of the brackets and divide by that. So, some examples. If we were integrating cos 7x, you can see here it's not just cos x, it's cos of 7x. You would work out that first of all. So really, that would be in brackets. So, you would integrate outside the brackets. Cos would go to sine, so we'd have sine 7x, but you differentiate what's in the brackets. So if you differentiate 7x, you get 7, and you would divide by that. So you'd have sine 7x over 7, or just put it to the side, so it's 1/7 of sine 7x. And again, you need that plus c. We did more examples here. It's clear where the brackets are. We've got 5 cos and then 3 minus x. So you're wanting to keep the 5 just as it is. You know you would have cos. So cos, when you integrate it, would go to sine. So it becomes sine 3 minus x. But if you differentiate what's in the brackets, 3 take away x is the same as 3 take away 1x. If you differentiate that, you get negative 1, so you have to divide by negative 1. So you could write it all over negative 1, or do as I've done here, you can write it as 1 over negative 1. From there, 5 times that 1 over negative 1 is just negative 5, and the rest will remain as it is. With this example here, again, you've got sine, you've got brackets, so integrate outside the brackets. First of all, leaving the brackets as they are, sine will integrate to go to negative cos. So we've got negative cos, and then the brackets are as they are. But if you differentiate what's inside the brackets, 12x minus pi over 3, well, you know pi over 3 is 3.14 divided by 3. It's just a number. So if it's a number, that will disappear, and your 12x will differentiate to become 12. So you divide by the 12. So you could write it all over 12, or again, do as I've done here, you could write it as 1/12, obviously with the negative as well. We did some more examples. These ones here were slightly harder. You've got brackets and it's all to the power of a half. So you know you add 1 to the power, divide by the new power, differentiate what's inside the brackets and divide by that as well. Here you've got the sign, so you're differentiating outside the brackets, writing down the negative just as it is. So writing down the negative 6 and then integrating the sine 3x. So for that, imagine there's brackets around the 3x. Sine would integrate to become negative cos, and then you would divide by the derivative of the brackets, which is why this negative 1/3 appears. 2 negatives make a positive, 1/3 of 6 is 2, and then you've got the rest just as it is. And obviously tidying that up, this part on the left. Here with this example, again, you're wanting to integrate. It's a 3x plus pi over 6. You can do that, but you're wanting to integrate between 0 and pi over 6. For that, integrate cos, you know that it goes to sine, so the sine and then leave the brackets as they are, divide by the derivative of the brackets, differentiate all that, you get 3, which is why you'd have 1/3 sine 3x plus pi over 6. From there, sub in the pi over 6 and sub in the 0 and evaluate that, and we get down to root 3 minus 1 over 6. That's a quick recap then of everything with this chapter of further calculus. Try the review lesson. Remember though, that is just the key points. If there's anything that you're unsure of, look back to the individual lessons and I will give more of an explanation. Best of luck. Let me know if you have any problems. Bye.